Welcome to this explainer. Today, we're going to distill physicist Jim Al-Khalili's absolutely mind-bending masterclass on the true nature of time. And look, you're going to want to go ahead and check your common sense right at the door for this one, because the reality of how the universe ticks is far stranger than you could have ever imagined.
Think about this. What if the past, present, and future all exist at the exact same time? Crazy, right? Well, we are going to shatter your everyday perception of reality and completely rebuild it using relativity, entropy, and the theoretical limits of time travel. By the end of this, the way you think about yesterday, today, and tomorrow is going to be completely transformed.
All right, let's jump right in with part one, the illusion of flow.
So to start, we really have to look at this massive disconnect between how we, as humans, experience time and what physics actually says about it. Basically, we might all be victims of a giant cosmic illusion. We feel this psychological flow, right? It's called manifest time. You know the exact feeling. An hour at an amazing party just flies by, but 30 minutes sitting in a dentist's waiting room drags on for an absolute eternity. But here's the kicker. In the fundamental equations of the universe, physical time doesn't flow at all. It's just a static number. It's just a humble lowercase t sitting there in the math. There's no mathematical river carrying us along whatsoever. Which leads us perfectly into section 2, Einstein's frozen block universe.
You see, Isaac Newton originally thought time marched on steadily for everyone everywhere, kind of like this absolute universally ticking cosmic clock. But Einstein completely dismantled that idea. To prove that time is actually relative, physicists look at things called muons. These are subatomic particles created high up in the atmosphere, and they have a tiny, tiny lifespan of just 2 microseconds. By all logic, they should decay way before they ever hit the ground. But they don't. Because they're traveling near the speed of light, relativity dictates that they experience time dilation. They literally live their short lives in slow motion, which allows them to easily reach the Earth's surface.
And hey, it's not just speed that does this. General relativity proves that gravity literally dictates time too, which means our GPS satellites out in space age differently than we do down here on Earth. Because they orbit farther away in weaker gravity, their onboard clocks actually run slightly faster than the phone in your pocket. If physicists didn't write software to constantly mathematically slow those satellite clocks down, the entire GPS network, including your Google Maps, would fail completely. Time slowing down isn't just some abstract theory. It is a literal engineering requirement.
This whole concept brilliantly illustrates what we call eternalism, or the block universe. If time is just a dimension, exactly like length, width, and height, then every single moment in time exists permanently. Think of it kind of like a completely written book. We are just experiencing the story page by page, but the beginning, the middle, and the end, they're already printed. They are all out there and equally real. Now, you're probably thinking, well, if the future is already sitting out there in this block universe, do my choices even matter? Al-Khalili points to a really neat concept here called compatibilism. Basically, because we are trapped inside the universe, we can't peek ahead at the next page of the book. And our complete inability to know what comes next means our choices in the present moment are still absolutely real and entirely our own. Let's keep moving. Section 3, the arrow of time. Okay, here's a massive puzzle. If the past and the future both exist right now, why do we only remember the past? Why don't we have memories of the future? Shockingly enough, nowhere, and I mean nowhere, in the fundamental equations of physics is there a rule that says time has to move strictly forward. The equations of motion are time-symmetric. If you play the mathematical tape backward, the physics works out just fine. Yet, in our reality, if you drop an egg, it shatters. It never ever magically reassembles itself. So where does that forward direction come from? Well, it comes from thermodynamics, and specifically entropy. The second law of thermodynamics dictates that isolated systems always decay from tidy order into messy disorder. Imagine a bunch of gas molecules neatly squashed into just one corner of a box. That is a highly ordered low entropy state. If you let them go, they're naturally going to diffuse and spread randomly throughout the entire box, right? That's increasing entropy. This totally irreversible transition from order to chaos is what gives time its one-way arrow. But actually, it goes even deeper than just gas in a box. Down at the quantum level, particles are constantly bumping into each other and becoming irreversibly tangled up with their environment. This irreversible tangling, which physicists call quantum decoherence, literally locks in the forward direction of time. As Jim Al-Khalili says, it is fundamentally baked right into the very fabric of reality. Moving into section 4, cosmic beginnings and ends.
If time is a one-way street, always pointing toward disorder and entanglement, we really have to ask, where did the road begin and where does it end? Looking back, general relativity tells us that time itself was created at the exact moment of the Big Bang. That means the whole concept of asking what happened before the Big Bang is completely meaningless. Stephen Hawking had a great analogy for this. He said it's exactly like asking, what is further south than the South Pole? Once you're at the South Pole, there's literally no more south. And once you're at the Big Bang, there is no more before.
So let's look forward on that timeline instead. Our present-day universe is currently being stretched out by something called dark energy. Because this mysterious dark energy is accelerating the expansion of space, time is very likely going to march us toward a cold, completely empty state known as the heat death, trillions of years from now. It's a point where everything is just too spread out for anything interesting to ever happen again. Now, scientists used to heavily theorize a cyclic big crunch, where the universe eventually collapses back in on itself to start all over. But the discovery of dark energy back in 1998 completely changed the game. Today, modern astronomy overwhelmingly points toward that heat death scenario, where the universe just dilutes outward forever until it reaches a flat thermal equilibrium.
And finally, Section 5, the time travel dessert. All right, time for a really fun hypothetical dessert. We've talked about time as a coordinate, as a block, but if it's a physical dimension, can we actually pack our bags and time travel? Well, traveling arbitrarily far into the future is entirely possible. Frankly, it's pretty easy in theory. If you travel fast enough in a spaceship or just hang out near a supermassive black hole, you'll age much slower than the people back on Earth, effectively skipping ahead into their future. But traveling backward into the past? That's where we slam into a massive brick wall of paradoxes.
See, traveling backward breaks the holy chain of cause and effect. The most famous example of this is the grandfather paradox. Imagine you go back and somehow prevent your grandparents from meeting. That means your parents are never born, and thus you are never born. But wait, if you never existed, who went back to ruin their blind date in the first place? Your own actions erase your own existence, which creates an absolute logical nightmare.
Now, some scientists argue we could actually avoid these paradoxes through something called the Novikov self-consistency principle. Basically, this means if you went back in time to try and change an event, you'd ultimately discover that your actions were already part of history. You literally couldn't change a single thing because your interference was the exact cause of the future you came from. It creates a perfectly consistent loop, though, yeah, it does completely annihilate the idea of free will in the process. Quantum mechanics actually offers a different loophole by suggesting that going back in time simply causes reality to splinter. You just emerge in a parallel alternate universe where your changes play out, leaving your original universe completely untouched. All that being said, many physicists strongly suspect we'll eventually discover that the fundamental laws of the universe just outright ban backward travel entirely. It keeps reality safe from meddling time travelers.
Which actually brings up a really fantastic point. Stephen Hawking cheekily asked, if backward time travel is possible, where are all the tourists from the year 3000? Seriously, why isn't our present completely flooded with people coming back to witness major historical events?
Well, the most grounded scientific answer to Hawking's question is pretty simple. You cannot travel back to a time before the time machine itself was actually constructed and turned on. Think about it. If the first functioning time machine is built in the year 2050, then a traveler in the year 3000 can only go as far back as 2050. They can't reach us today simply because the door hasn't been opened yet. So I'm going to leave you with this final crazy thought. Given that our ancestors used to think the Earth was the flat center of everything, what mind-bending secrets about time are still waiting out there to be discovered? I mean, our grasp on time has evolved from a cosmic ticking clock, to a rigid block, to an entangled quantum web. The universe is incredibly vast, and its ultimate truth might just be waiting for the next Einstein to come along and turn everything we think we know entirely upside down.